is there's not really a good shared platform. Like I said, there's like 100 different people and they're all like going in different directions, which is good because from an evolutionary standpoint, eventually someone's going to stumble on the most kick-ass way of doing things, and then everybody else is going to jump on that bandwagon. Third, we really need to get really repeatable results. We need to know that if you print this design 100 times, out of that 100 times, there's not going to be a single error. So it's really just improving the technology, striving for that Six Sigma of very little errors. Fourthly, the costs are still pretty high. I mean, if you want to get a good CNC machine, you're looking at about $1,000, which is amazing considering how years ago it was 10 grand. And the fact that the cost keeps dropping is really exciting and intriguing. I hope that within 10 years, you can get a nice machine for under 100 bucks. Just like you can get a nice laptop these days for, $300-400 bucks. Also, there's a very large learning curve on the software, the hardware, the electronics. I mean, in order to build one of these machines, you either need to have a very diverse set of competencies, or you need to have a lot of friends that each know a ton of stuff about one area. I would like to see this stuff just become drastically simplified so that you download the program, it sort of can either figure out how your machine works or it just is very easy to configure. So making the stuff simpler and easy to use will allow more people to get involved. So say you're a 3D modeler. You know all sorts of tips and tricks for using Blender. But if you can't figure out how to get the stepper driver to drive the stepper, then your machine's not going to be able to make anything. So getting that to be a lot simpler and easier to use is going to go a long way towards making this widespread. So how do we get there? First of all, if you're interested in this, get yourself a machine. You can beg, borrow, or steal and get one of these machines and just start working with it. The hands-on experience you're going to get from just messing around with this technology is going to do more for you than any other thing you can do. Just playing around with a CNC machine it's a wonderful experience. Second, and a little bit selfishly, contribute to Thingiverse.com. It's an open design site for uploading your open source designs. It does a lot of really cool things that I won't go into, but it's fun. Secondly, if you don't really have a particular machine that you want to get and work with, get a RepRap machine. We're trying to make a machine that will make copies of itself, be able to make new parts for itself. It's totally, absolutely open source. So you can just do whatever you want with this thing. You can build 1 million of them and sell them to everybody else. And if you do that, I'll high five you. Let your friends know about it. If you have friends that are interested in technology or hacking or just interesting things to do, saying, hey, let's build a machine that builds machines and build machines. That'd be fun. And finally, learn as much as you can. If you have a brain, stuff more stuff into it. And I don't think anybody's brain has ever exploded from too much knowledge. So you could be the first. So, in summary, digital fabrication is a real technology. It's coming to a house near you, and you should work smarter and not harder. When the mainframe computer came out of the realm of research laboratories, military compounds, and corporate centers into the hands of normal, average human beings, there was an explosion of software available and innovation. Putting advanced technology into the hands of creative individuals will have surprising and most excellent results. Who could have predicted Google, Amazon, Facebook, SourceForge, or YouTube? Would these things have been created if one needed an expensive budget to purchase a mainframe computer? I find that unlikely. Thank you for listening to my crazy ideas. If you want to go on the internet and get involved or check things out or like find out why I'm so crazy, here are some good places to go. There's places where you can share designs, there's places where you can find out about the technology, and then there's places where you can talk with other people that are interested in it. Yeah, questions? This is the fun part.
Hi. So I don't know anything about this, so I'm looking forward to be educated here. First question, is there anything that looks like a sort of like a universal markup language that's agnostic, that's kind of like architecture or machine agnostic? So like something that says like in this coordinate system a physical markup of whatever it is that you're trying to build, and then some sort of material specification. That's one question.
So this is definitely something that's being actively developed. You can sort of break it down into two different categories. There's 2D design files, and then there's 3D design files. So with things like laser cutters or water jet cutters or things that it's just like a beam that cuts material, it's all vector art, which is really, really, really easy to get into. There's really nice open source programs for doing these designs like QCAD and Inkscape, and there's also really nice commercial programs like Adobe Illustrator is amazing. Obviously it costs money, but you can just design these things in normal programs. For the 3D side of things, basically you create a 3D model, and then you run that 3D model through some sort of slice and dice program that says, okay, this is a 3D model. What do we need to do to translate that into a machine-specific thing? So,
so really for some sort of markup language, it really just needs to say, in coordinate system X, do Y. I'm surprised. I'm a little surprised that doesn't exist.
It does exist, but it's more machine specific. Like there's no like overarching one type of language. There's something called G-code, which is what the vast majority of CNC machines do, but that's like go X to Y to Z. And so the generator that generates that code needs to know information about your machine in particular. So it needs to know how big the drill bit is on your machine and so on and so forth.
Hi. You said that your toy soldier manufacturer needs to make 1 million of them to get the economies of scale so that it's economical to do so. Do you envision producing them, each one different, using this kind of technology to ever become as cheap as the mass production we currently have? And if not, do you think the added value is going to be worth it?
It probably is never going to be cheaper to have a machine go piece by piece and build up a toy armament than it is to have a giant machine that'll stamp out 500 of them in one go. But the thing is that I feel that people will value the ability to customize and build the things that they want more than being able to just get one of something. The other thing is, I didn't really get into it during the talk, but by revolution, I don't mean that this is going to completely replace the existing system. Open source has been completely revolutionary in the world of software, but there's still Microsoft. There are still tons of people out there that are selling software, and I think that's excellent because these things can coexist. There's a reason for all of them to be there. So with the toy soldier example, it's great to be able to just mass produce something because the design's already excellent and it's cheaper to do it that way. But also being able to control the design yourself and make modifications is very valuable. So I plead both.
Thank you. Can you show us a few examples of things you did? So I'd really like to see something like that.
I guess I can go on Thingiverse here. The other day we had this thing called the Laser Battle 2008. And so basically we set up these rules for this contest. You had to use 12 inches by 12 inches, 308 millimeters by 308 millimeters of whatever material you want and laser cut something out of it. So I decided that, oh no, I don't have the internet here. So I decided I wanted to make a pump out of it. So I make a pump that fits onto 12 by 12 inches of quarter-inch acrylic. You laser cut it out. You bolt it together. You put a little bit of tubing in there, and then you have a working pump that can pump whatever you want. So I'm going to use that to build a drink serving robot. But the idea is that you could just download it and make something. In the way back? Or the front? That's easier.
I'd like to know if you've thought about the ecological implications of this. I mean, if it's going to be all over the world and everyone producing whatever they want to produce, how is it going to be ecologically sustainable?
Well, I mean, for one thing, you won't have to. Let me rephrase the question. I think he asked how it's going to be economically sustainable if... Oh, ecologically. Well, first of all, this is both economic and ecologic. You won't really have to pay for shipping all of the finished goods from point A to point B. So there'll be a lot less traffic on the roads of shipping things around. You will still have to ship the raw materials, but instead of shipping the raw materials from wherever they're created to a factory and then building these things and then shipping them on to the end point, the raw materials will just go straight from where they're built to where they're needed. Secondly, what we're trying to do is with at least RepRap, it's a thermoplastic, so theoretically you should be able to grind it up, remelt it, and build new things. So if we create open source recyclers, you will be throwing out less stuff because you'll be able to reuse the things that aren't useful anymore.
Oh, hello. I'm wondering about the limitations regarding form and materials. I think there's only so much you can do with a laser cutter or a 3D printer. Maybe I'm lacking imaginations. Are there any new technologies on the horizon, or what are your ideas?
The thing about this is that there's not really any new technologies out here. The powerful thing is taking these existing technologies that are already used to do a huge amount of things, but putting them in the hands of average, ordinary people that can then think up new and exciting things to do with them and then use them for their specific purposes. I mean, there's a wide variety of different things that you can do with a laser cutter or a 3D printer. And it's really up to your imagination to figure out what to do with them.
Can you give some numbers, how much time and money it would take me to build such a RepRap for making tin soldiers, plastic soldiers, and how long such a machine takes for making one small thing?
So right now, I think just like a ballpark figure to build a RepRap machine, you're probably looking at around $750. Sorry. But it's really a time versus money trade-off. If you have a lot of time but not a lot of money, then you can cut corners and save money. But if you don't have a lot of time and you have a lot of money, there's a lot of high-end stuff here that you can buy that is just going to bolt together and work, and you'll be able to just get started right away.
Hello. Is there existing license for open source objects? Because someone can make a patent on it and earn money up.
That's a very good question, and I don't really think there's a good answer for that yet. I've chatted with a few of the lawyers from the Software Freedom Foundation,